Greetings, everyone. So today we are going to cover the topic of pair of linear equations and solving the pair of linear equations using a graphical method. So it's a pair of linear equations using graphical method. Okay, all right. So let's first understand what are the pair of linear equations. Before we get into the pairs, first let's understand what is a linear equation, right? So a linear equation is something which is in the form ax plus by plus c equal to 0. So an equation is nothing but which has both the left hand side and the right hand side. Here, this ax plus by plus c is the LHS left hand side, and this is equal to 0. The other side of the other side of the equal to is our right hand side. So left hand side and right hand side. So here A, B, C are the variables, constants, okay? And X and Y are variables like X and Y. So two variables. So that's why we say this AX plus BY plus C equal to 0 is a linear equation of two variables. The variables here are X and Y. So when we talk about a pair of linear equations, right? So can I write like A1X plus B1Y plus C1 equal to 0 and A2X plus B2Y plus C2 equal to 0. So these two are the pair of linear equations for variables, for two variables X and Y. So A1, B1, C1 and A2, B2, C2. So now, for example, let's consider one equation. Okay, so I can say 2x plus 3y equal to y. Okay, so for example, if I take x equal to 1 and y equal to 1, then substitute in that value. So what is our LHS? The left hand side of the above equation is 2x plus 3y. So if I substitute that value, 2 into 1 plus 3 into 1, so that becomes 5. So that is matching with our right hand side, RHS. So this value for 1 for x and 1 for y are the roots or the solution for this pair of this linear equation. 2x plus 3y equal to 5, where x equal to 1 and y equal to 1 are the solutions or the points on that linear equation. Okay. So for a pair of linear equation, so now we looked at one equation and there may be various values of x and y for which we can satisfy both right hand side and left hand side. So all such values for x and y are called the solutions for that linear equation. How about a pair of linear equation? So when I say pair of linear equation, there are three possibilities for that, right? So let's say this is one line, right? Now, if I have another line here like this, right? If I extend this line, it's supposed to be a straight line. 1 minute. So let's say I have this one line here. And if I extend this line, this can come like this. And so what is happening here? So it is intersecting at this point. Both the lines are intersecting at one point. These type of lines are called intersecting lines. Okay. The pair of lines which intersect at one point are called intersecting lines. Similarly, I have two lines here, right? And another line here. So if I extend both the lines, they just go parallelly. They never intersect. Such lines are called parallel lines. Okay? Such lines are called parallel lines. Now, there is another scenario. So one is intersecting lines, one is parallel lines, and another is, let's say this is one line, right? I have another line exactly on top of this. So these are called coincident lines. These are called coincident lines. So here we will see like what is the difference and how to find which lines are intersecting, which lines are parallel lines, and which are coincident lines. So intersecting lines. So the basic property for the intersecting lines are, let's say the lines are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. In this case, if this satisfies, like a1 by a2 is not equal to b1 by b2. So the coefficient of one variable, that is x, the ratio of the coefficients of x variable, that is a1 by a2, when it is not equal to the coefficients of the other variable, that is y, that is b1 by b2, then we say these lines are intersecting lines. Okay. And similarly, parallel lines. What behavior that parallel lines should have? Parallel lines like a1 by a2 is equal to b1 by b2, but not equal to c1 by c2. So here we are doing the ratio of a1 a2, b1 b2, and c1 c2. Here a1 by a2 is equal to b1 by b2, but not equal to the ratio of the constants. Such lines are called parallel lines. So in terms of intersecting lines, how many solutions we have? We have a unique solution, right? We have a unique solution. And also these lines can be called as consistent lines. Which lines? These ones. The intersecting lines are also called as consistent lines. So here, three three parameters we have covered. A1 by for two pair of linear equations to be coincident, so to be intersecting lines, we need to have A1 by A2 is not equal to B1 by B2. That criteria has to met. So if that meets, then that is that those lines are intersecting lines and it has unique solution, means one solution. They intersect at only one point. And then these lines are also called as consistent lines. Next, what are parallel lines? For a pair of linear equations to be parallel lines, it has to satisfy the criteria A1 by A2 equal to B1 by B2, but not equal to C1 by C2. If that criteria satisfies, those are parallel lines. And how many solutions we'll have for a parallel line? So for example, if you consider parallel lines means they just go at some width, some distance, and they never intersect. So when they never intersect means there is no solution. So these lines never intersect. So there is no solution for parallel lines. It's just like a railway track. So the two sides of the railway track, they never intersect, right? Like that. So those are the parallel lines. And these lines are called inconsistent lines. That means they are not they do not have a solution. So these are inconsistent lines. There is no solution for them. Now we have another scenario where it is coincident lines. What are the coincident lines? For the coincident lines, the criteria is A1 by A2 should be equal to B1 by B2, and that is also equal to C1 by C2. So when the ratio of all these constant, like A1 by A2, B1 by B2, C1 by C2, if all these three ratios are equal, then we say these lines are coincident lines. So what happens to the coincident? How many solutions we have? So we will have infinite solutions, because any point on this line is a solution, right? Any point on this line is a solution. So there are infinite number of solutions. How many solutions? Infinite number of solutions. And whenever there is a solution, we call those lines are consistent. Okay, so these lines are also consistent, but infinite solutions. But the first one, intersecting lines, are consistent and unique solution. How about the parallel lines? Parallel lines are inconsistent lines and there is no solution. Okay, hope this is clear. So there are three possibilities for a pair of linear equation: intersecting lines, parallel lines, and coincident lines. Okay, now let's take any one pair of linear equation and see how to solve it. Okay, so let's take one example here. Okay, so For example, I have a linear equation, pair of linear equation here. X plus 2y minus 4 equal to 0. That's one equation. And then 2x plus 4y minus 12 equal to 0. Okay, let's see. So how to put that in a graphical method, right? So we are looking at the graphical method. So first let's draw a graph here. This is a rough sketch, okay? So when you are drawing in the board exam, you will get a rough graph paper, and you need to exactly take the scale, and you need to draw it the scale properly. But here, for your understanding, I'll just go with a rough sketch here. Okay, so what I will do here. So the first equation is x plus 2y equal to 4. So here what I will do is, first I'll take a value of x and value of y. For simplicity, what I'll do is, once I'll substitute x as 0, and I'll find the y value. And then in the next case, I will substitute y as 0 and find the x value. Okay, so that way I just need 2 points to draw any line, right? So I am taking x as 0. So in this equation, if I substitute x as 0, then 2y becomes 4, then y becomes 4 by 2, that is 2. Okay, I'm not writing the calculation here, but I think it's self-understood, right? And now I'm substituting y as 0. So if I substitute y as 0 here, 2 into 0 is 0, and x plus 0 is 4, so x is 4. So I got 2 points here. So what are those points? 0, comma 2 is 1 point, and 4, comma 0 is another point. So now let's look at 1, 2, 3, 4. Similarly, on the y-axis, 1, 2, 3, and 4. Now, what is the first point? 0, comma 2. So here the points are 0, comma 2 and 4, comma 0. So 0, comma 2 is a point on y-axis. X-axis is 0 and y-axis is 2. So this is 1 point, 4, comma 0. So x-axis point, y-axis y coordinate is 0. So if I draw this using a scale, right, it will exactly, it should go through that point 4, comma 0. Let me redraw that. Okay. So if I join these 2 points, the line should be like this. If you draw with the scale, it will exactly pass through that. So this is one line. Now, let's find the points for the other line. So what was the other line? This is the line, right? So let's substitute x and y values for that, and then draw the line. Okay. So let's substitute x as 0 and y as 0. When x is 0 in this, then 4y becomes 12, right? So this line I can also write as 2x plus 4y. That minus 12, if I send to the other side, then it becomes equal to 12. So if I substitute x as 0, 4y becomes 12, then y becomes 3, right? And when I substitute y as 0, 2x becomes 12, then x becomes 6. So here the points are 0, 3 and 6, 0. So what is 0, 3? 0, 3 is a point on y-axis, and 6, 0. So I need another 2 points. So let's say this is 5 and this is 6. Now, if I see this, I am getting this line. So if I see the nature of the lines, are these intersecting lines? No, no, right? Because they are not intersecting at any point. They are parallel lines. So these are parallel lines. Parallel lines means no solution, and these are non-intersecting. These are inconsistent lines. Yeah, these are also called as non-intersecting. But in terms of the board terminology or the textbook terminology, these are parallel lines. These lines do not have any solution, and these are called inconsistent lines. Okay, so now we just saw, like, we got a pair of linear equation. We just solved them to find 2 points on each line, and we just draw the line on a graph. And now, if these are intersecting lines, both the lines both the lines will intersect at one point. That will be the solution for that line, that unique solution we said, right? The intersecting lines will intersect at one point, and that is the unique solution. So that you can find from the graph. So the example, the pair of linear equations that we took here, these are parallel lines. So parallel lines do not intersect anywhere, so there is no solution. Okay. So hope now you understand how to draw using how to draw the lines using graphical method. So let's take another example, right? This time, hopefully, we will have something like an intersecting line. So let's see. So in board exams, right, they will not make our life this easy, right? So what they do basically, they give some descriptive, right? They don't give the equations directly. They give some descriptive problem, right? So they will say like, for example, let me, I just note down one problem. So they are saying 2 kg of apples and 1 kg of grapes is 160 rupees. So they don't give the equation directly. So listen here carefully. So the problem is 2 kg of apples and 1 kg of grapes costs 160 rupees. And 4 kg of apples and 2 kg of grapes cost you 300 rupees. Now find the cost of each kg of apple and each kg of grapes, right? So here, what are the variables? So in this problem, they're talking about some quantity of apples and some quantity of grapes. So I'll take apples and grapes as variables here. So let x equal to 1 kg of apple, right? Let y equal to 1 kg of grapes, right? So what was the problem? 2 kg of apple and 1 kg of grapes. So can I say 2x plus 1y equal to 160? This is in rupees. So our assumption should be x is the cost of 1 kg of apple or the price of 1 kg of apple. Similarly, y should be, because we need to see in which terms it is given. Is it given like a quantity or in terms of price? So here it is a price. So 2x, 2 kgs of apples plus 1 kg of grapes is costing 160 rupees. This is one equation. And the other equation says 4 kg of apple and 2 kg of grapes. So 4x plus 2y is 300. This is our equation 2. So now we have the equations we can easily do using the graphical method. Earlier in the problem, unless you get to the equation, it is very difficult to solve the problem, right? So from the descriptive, assuming which are the variables and then deriving these equations is very important. So if you are able to give the equations correctly, half of your problem is solved, because you anyways know how to solve these pair of linear equations using the graphical method. So now what I will do is, in this equation, for the equation 1, which is 2x plus y, 1y means y, equal to 160. So I will take x and y, right? So I'll substitute x as 0, find the value of y, and then substitute y as 0 and find the value of x, right? Now let's see. If you substitute x as 0, 2x plus y is 160, then y becomes 160, correct? And if you substitute y value as 0, then 2x is 160, then x is 80, right? So the points here are 0, 160 and 80, 0. So now our graph should be such a way that our scale should be like this, 80, 160, right? So we need to see what proper scale that we need to use, because the points are not like 1, 2, 3. Here it is 80 and 160. So I'll tell you how to take the scale. Now similarly, find the points for these. 4x plus 2y is 300. Now See, I am taking 0, x as 0 and y as 0 at a time to get the points very easily. You can substitute any values. You can substitute 1 for x, you will get a different value of y. You can substitute 2 for x, you will get a different value of y. So you have 2 points. Indicate those 2 points and join, you will get the line. Okay. For simplicity, for the easy calculations, I am substituting x as 0 one time, finding y, and y as 0 and finding x. Okay. You can follow this. All right, so 4x plus 2y is 300. When I put x as 0, then 2y is 300. Then y is what? 150. Good. Now I substitute y as 0. Then 4x is 300. That means x is 300 by 4. That is 75. Okay. Now I know both the points for both the lines, right? So one is 0, comma 150 and 75, comma 0. All right. So did I get any common point here? No. So from the graph, we need to find which is the common point. Okay. So now you need to see which is the best way, what scale that you should take. So as the points are in 160, right, highest. So I will take each centimeter in the graph, each centimeter in the graph has 20 units. So 20, 40, 60, 80, 100, 120, 140, 160. That is the max. So 160. Similarly, here also you need to take same scale. 20, 40, 60, 80, 100, 120, 140, and 160. Okay. All right. So the first point for the first line, 0, comma 160. 0 is this, 160 is here. Okay, that's one line. And 80, comma 0. So 80, comma 0 is this point. So if I need to be careful here because I'm drawing with freehand. Oops. Okay. Yeah, it's going approximately. That's fine. Now the second line is 0, comma 150. 0, comma 150 is somewhere here. And then 75, comma 0. So 70, okay, 75 is somewhere close to 80. Yeah, that's why if we have the scale, right, then we will know, basically. Let's see. Yeah, I think these are also parallel lines. These are also parallel lines. Let's verify. So we did not get a solution. These lines are not intersecting, right? So let's see according to our formula, right? Our criteria. So what is the criteria? For this to be a parallel line, A1 by A2 is B1 by B2. That should not be equal to C1 by C2. Okay, now we got the parallel lines. So let's now verify what is A1 by A2 and B1 by B2, right? So A1 is 2, B1 is 1, and C1 is 160 here, right? Minus 160. It's actually A1x plus B1y plus C1, right? So if we send this 160 to that side, then it is minus 160. And similarly, A2 is 4, B2 is 2, and C2 is minus 300. Now, what is A1 by A2? A1 by A2 is 2 by 4, and B1 by B2 is 1 by 2, and C1 by C2 is 160 minus 160 by minus 300. So A1 by A2 is 1 by 2, B1 by B2 is 1 by 2, and this is not 1 by 2. If it is 320, then it would have been 1 by 2. So this is some value, right, which is not equal to 1 by 2. So this is equal, but this is not equal. So can we say this is not equal to 1 by 2, right? This is some other value. Some value we will get. So these are parallel lines. These are parallel lines. So this is how you can find using the graphical method. If there are any intersecting lines, then you would have got these two lines intersect at one point. That is the solution of for those pair of linear equations. So just to recap now, right? So what we have learned in this topic, so the pair of linear equation and solving them using the graphical method. So here, the pair of linear equation is in the form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So the three possibilities for these pair of linear equations, right? So that is, the three possibilities are, it can be intersecting lines or parallel lines or coincident lines. So we just looked at what are the intersecting lines. Intersecting lines have a unique solution, and the criteria is a1 by a2 should not be equal to b1 by b2. And then parallel lines. Parallel lines are a1 by a2 equal to b1 by b2, that not equal to c1 by c2. So there is no solution, and these are called inconsistent lines. Coincident lines. Coincident lines are both lines are on the same line. The both are same. You cannot distinguish. So those are coincident lines. So for that to be for any pair of linear equation to be coincident lines, it's a1 by a2 equal to b1 by b2, that equal to c1 by c2, and it has infinite solution. Any point on those lines is a solution. So that's infinite solutions, and those are also consistent lines. Then we looked at how to draw using a graphical method, how to draw the lines using graphical method. So basically, you take a x coordinate 0 one time and y coordinate 0 one time, find the other point for each line. So you will get 2 points for line 1 and 2 points for line 2. Based on those 2 points, depict the graph. So once you draw the graph, you will see what kind of lines they are. And you can also validate using the criteria that we know. So we did two examples today. Both the examples are parallel lines, right? Both the examples are parallel line. And you can also verify before even you do the problem. For example, in the board, they just give two lines and they will just ask you how many solution it has. The options will be like unique solution, no solution, infinite solutions, none of the above, right? So for that, you don't need to solve the equations. So just verify the coefficients, a1 by a2, b1 by b2, c1 by c2. If a1 by a2, b1 by b2 not equal, then coincident lines, unique solution. If a1 by a2 equal to b1 by b2 but not equal to c1 by c2, then it is parallel lines. Parallel lines means no solution. If all are equal, then you will say infinite solutions. These are coincident lines and also consistent. Okay, so that's about the topic, and hope you all understood. Thank you for your time.